So, in an observational study, the researcher merely observes what is happening or what has happened in the past and tries to draw conclusions based on these observations. In an experimental study, the researcher manipulates one of the variables and tries to determine how the manipulation influences other variables. Okay, these two are super important. Independent variable. Now, this is no different than it has ever been in math. The independent variable is what we change. The dependent variable depends on what you did to the independent in order for you to be able to determine the outcome. Okay, that has never changed. For X and Y, what was our independent? X, dependent, Y. Okay, now you have to apply this to verbal situations. Okay, so that's the only difference, but you should still understand the concept. It hasn't changed since Algebra 1. So your independent variable in an experimental study is the one that is being manipulated by the researcher. The independent variable is also called the explanatory variable because it explains why. The resultant variable is also called the dependent variable or the outcome variable. So just like when we were in algebra and I'm like, hey guys, remember roots, solutions, x-intercepts, all this means the same thing. You have multiple ways that I can ask. So you have to know, if I ask you about the explanatory variable, you have to know I'm talking about independent. If I ask about the outcome variable or the resultant variable, you have to know I'm talking about the dependent. So it's just terminology you have to learn. Is that okay? Because it may say it one way in one question and a different way in another. A confounding variable is one that influences the dependent or outcome variable, but was not separated from the independent variable. An example, subjects who are put on exercise program might also improve their diet without the researcher knowing, and perhaps improve their health in other ways, not due to exercise alone. So while the researcher's only looking at exercise, they may be changing things that are also affecting the outcome. That would be a confounding variable, okay? If I'm trying to determine Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, which day of the week is the hottest, I also have to look at the time of year, because you get to this time of year now and you get a cold front that comes through in the middle of the week and all of a sudden it affects the rest of the week. That may be a confounding variable that wasn't taken into account. It's time of year. So there's always things that can affect your outcome that may not necessarily be the thing that's being tested, okay? All right, uses and misuses of statistics. So the use of statistics to evoke fear would be a misuse of statistic. This is what advertising companies do all the time. You have to determine, is it legitimate or is it not legitimate statistics, okay? So suspect samples, 3 out of 4 doctors recommend brand X. Great. How many doctors were sampled? Was it 8? Because that doesn't mean anything. If it's 100, then it may have significance. But depending on how many doctors were actually talked to, that statistic doesn't really have any value because you don't know how many people they talked to, okay? If I poll you guys and then I poll my 8-person algebra or geometry class, I can't say that those results should be the same. Ambiguous averages. The average price of homes in neighborhood X is $500,000. Well, how many homes are in the neighborhood? Are we talking about out in the country where there's like 5 homes in a square mile? I mean, so you have to look at that kind of stuff. Changing the subject. So, according to the Times, political candidate X states that expenditures were only raised by 3% during his administration. That sounds positive. Well, their opponent's going to say, according to the Daily, political candidate X has raised expenditures by $6 million during his administration. Well, that sounds negative. They're saying the same thing. The problem is, what were expenditures? Are we talking about, is it based in the millions? Is it based in the 10 millions, the billions? That has a huge effect on this statement right here. Whereas 3% is comparative. Does that make sense? So again, none of this may be actually stating anything that is false, but that doesn't mean that it's a good use of the statistics. That's what advertising does, to be perfectly honest, especially when you're trying to make another brand sound negative. You can change what the statistics make it sound like, even if you're not lying about the facts. Another misuse of statistics is detached statistics. So brand A medicine works 4 times faster to relieve pain. 4 times faster than what? What's it comparing it to? So if you don't know what it's comparing it to, how do you know what it's, because it may be 4 times faster than Tylenol, but not 4 times faster than Advil. So maybe it's not that good of a drug. Implied connections. Eating fish may help reduce cholesterol. Studies suggest that using our exercise machine will reduce your weight. Taking calcium will lower blood pressure in some people. So all the underlying phrases are loopholes, because if you come at them and say, well, this didn't work for me the way you advertise, they're like, oh, but we said that some people, you're just not one of the people that it helps or that it affects. So those are loopholes. Misleading graphs. That's the one that probably is used the most, and I'm going to give you a visual for that one. Faulty survey questions. So when analyzing the results of a survey, you should make sure that the questions are properly written and not influencing the ones taking the survey. So do you feel that Township High should build a new football stadium versus do you favor increasing taxes in Township so that the high school can build a new football stadium? Most people will say okay to the first one, but when they find out they're paying for it, they may stop and think, do I really think they need that? So that's going to have an effect based off of how you ask the question. I don't think I have it in your notes, but one of the misleading graphs, one of them, the more common ones that I've seen, kind of looks like this, where I give you 3 bar graphs. Those are the same based off of the scale of your Y factor. If I have the left side, that's 95, that's 97, that's 99. Depending on what we're talking about, that has a much larger jump and makes it look like this third graph is less than the first one, whereas when I put it on a correct scaling for my y-axis, which would be the right one, there's not much different. Okay, so again, you always do need to pay attention if you're being given a graph. Look at the scaling, look at that kind of thing to make sure that it's not misleading or giving you false information. All right. Example 1, e-cigs have increased dramatically over the past 5 years. Compared to traditional tobacco products, a lot of research has not been performed on alternative smoking devices, even though the sales of these devices have doubled and then tripled. One study conducted at Virginia Commonwealth University considered the following factors: carbon monoxide concentration, heart rate, subjective effects of the user, and plasma nicotine concentration. The study consists of 32 subjects. The subjects came from 4 separate groups: traditional cigarettes, 18 milligram nicotine cartridge vapor brand, 16 milligram nicotine cartridge vapor brand, and a device containing no vapors. After 5 minutes of smoking, the smokers of the traditional cigarettes saw increased levels of carbon monoxide, heart rate, and plasma nicotine. The electronic vapor cigarette smokers did not see a significant increase in heart rate or subjective effects to the user. Answer the following questions. Statistics is a lot of this. They give you a scenario, and you've got to be able to pull information from it, okay? So what type of study was this? Was this observational? Was it quasi-experimental, so part experimental, part observational, which we're not going to do a lot of, just FYI, or experimental? So were we observing a previous thing, or are we actually testing it right now? We're testing it right now, which makes it experimental. What are the independent and dependent variables? So independent, what was being changed? Smoking device, perfect. That based off of when the study occurred. So I'm looking at a study from 10 years ago. So this was their information that they're given, so I make an observation and make an assumption based off of that. Does that make sense? Okay. Dependent. So the three different things that they're testing, which is carbon monoxide, heart rate, and plasma nicotine. Which was the treatment group? So which was your group that you're using as a baseline that has nothing that's being affected? The one with no vapor. So that happens a lot in any of these types of experiments. Is you always, or another way to say it is a control group. That's probably the terminology you've heard most frequently. So the treatment group or the control group was the group with the containing no vapors. Because you don't know how much something's changed if you don't have a baseline. Could the subject's blood pressures be affected by knowing they're part of a study? What can cause your blood pressure to increase? Stress, nerves. Could that be affected if you know you're part of the study? Yeah, it might be. So not yes, but not no. So maybe is a perfectly okay answer. List some possible confounding variables. There's several.
Heart issues.
Okay, previous health factors. What else?
How if they have done it before, I guess, if their body's used to it.
I'd say that probably can go ahead and go under previous health. There's two very obvious ones that are always affecting it. Age is one of them. And what's the other? Gender. Generally speaking, especially when we're talking medical, age and gender have a huge difference sometimes. I mean, you think about life expectancy of males, life expectancy of females. Certain issues affect males more, certain issues affect females more. So that can have a major effect that is a confounding variable in a medical study. Do you think this is a good way to study the effects of smokeless tobacco? Did you think that this represented a good study? It's okay. Could it be improved? Yes. I don't think this is a bad study. It could be improved.
So how would we know if it's a good or bad study? Like, is it kind of just subjective or just based on?
It was a random sample. It wasn't convenient. So generally speaking, that is going to help us. We had a control group. That's another good basis of it. But most of y'all are like, yeah, I mean, we just talked about different confounding variables. How would this have been a much better study if I had said we looked at people ages 35 to 45 or, an equal number of males and females? So if they had stated that, then I would say there's probably not much improvement that we could have done because that would have narrowed down a lot of our outcomes. Yes.